Hello, welcome to the first video of this playlist. In this playlist, I will teach you all the things about Docker. This video is an introduction video where I will teach you what is Docker, what is container, all the concepts about Docker. So it will be a theoretical video. You guys have all heard about it works on my machine. In production scenario, let's suppose you're working on a team and multiple people have multiple OS and they are developing an app. Let's suppose your coworker has Mac, other coworker has Linux, and you have Windows, and you are building an application on Windows, and they are using other OS. So your app can crash on their OS. In this scenario, your application is very tightly coupled with your OS. So how you can solve it? This is solved using Docker. Another problem. Let's suppose you have two applications. One application is using Node version 11 and other one is using, let's suppose, Node version 20. So it's very hard to manage the dependencies of two other versions of Node in the same operating system. Also, another problem is lack of isolation. What is lack of isolation? If you are running your database, your application, and multiple other kinds of dependencies in the same OS, one dependency can affect on other one. So your application might get crashed. All of these problems are solved using Docker. So what is Docker? Docker is an open source platform which provides all of this: standardization, portability, and isolation. And all of these things are achieved by containers. So what is a container? Container is a lightweight standalone executable package of your application that includes everything needed to run your application. Container actually packages your application into an isolated environment so you can run and manage multiple applications same OS. So it sounds similar to the virtual machine, but there are differences between the virtual machine and containers. So let's focus on the architecture. Here you can see this is the architecture of virtual machine and this is the architecture of containers. If we look at the architecture of the virtual machines, we can see that virtual machines virtualize the entire machine down to hardware layer. Like you can see that in on top of infrastructure, there is a thing called hypervisor, and hypervisor is actually managing your multiple OSs. You can see that hypervisor is running the multiple OS. Here is one guest OS, here is three guest OSs running on, and it's separated and isolated from each other. But it has lots of overheads, like you need a separate OS for each application. And another thing is it consumes more memory and more CPU spaces. If you have used virtual machine, you have seen that before creating a virtual machine, you need to partition these hard disk spaces. So there are lots of overheads of virtual machines, but containers are lightweight. In containers, applications are using the same underlying infrastructure. We are not actually virtualizing the whole infrastructure. We are actually isolate our application at the OS level. So there is less overhead, and we don't need to run multiple OS. That's why containers are more preferable. On virtual machines, you have seen that one virtual machine can take up to lots of GBs of memory, but containers take hardly megabytes of sizes. So what is Docker? Docker is a platform which actually helps our application to package into one standardized container, and we can build, run, and manage our container inside Docker. So what are the benefits of Docker? We can standardize our whole application. Like you can see, app A is totally isolated from app B. So if we want to use other versions of Node application, we can run Node version 20 on this container, and other container can hold the Node version 20. So it won't break anything because everything is isolated from each other. Other point is portability. Docker containers are very portable. As I have explained it to you, we don't need multiple operating system to run one container. So we can easily share our container across the teams. It's very portable. And the third point is isolation. Docker containers are isolated from each other, so one application won't cause any trouble to another application. And now we know containers. But what is an image? A Docker image is a read-only template that contains everything needed to run an application, including the application code, library, dependencies, and all of these things. And Docker containers are actually Docker images in runtime. Now let's get our hands dirty on Docker. Let's go to this website docker.com and download the Docker desktop application. according to your OS. You can download it for your OS. Like if you are using Linux, download the Linux version. If you are using Mac, download the Mac version. I have Windows, so I have downloaded the Windows version. If you have successfully downloaded your Docker Desktop application, you will get to see that user interface. This is Docker Desktop GUI application, and you can see that you can open your terminal using Docker Desktop. Let's run an Ubuntu container inside Docker. So before running the container, we know that we need the image, container image. So we need to pull that image from Docker. So if we run docker pull Ubuntu, this is the name of this image. If we run this, then Docker will pull the image of the Ubuntu container. You can see that it's downloading the latest version of the Ubuntu. You can also specify the version. So you can see that if we go to our Docker images section, you can see that there is an image, and it's the size of this image is very less, 78 MBs. And if you want to see the running images using Docker CLI, then you need to run Docker images. Yes, you can see that this is the image. Now you need to run this image as a container. So what you will do now, if you want to run the Docker container, you just need to run the command docker run, and you need to provide the flags. IT means interactive mode, and D means you need to detach from your container, and you need to specify the image name. You can see that this is the container ID you are getting, and if you go to the containers, you can see that your container is running, and this is the CPU that it's consuming. If you want to get into that container, you can get to see the files. These are the files inside the container, and if you want to run any command that is Ubuntu specific. Now if you want to see the OS, you can write the command uname. You can get to see that it's Linux. If you want to get inside of your container without using Docker Desktop, you just need to run docker exec -it flag, and then you need to put the container ID. This is the container ID, and you need to specify this shell. You can see that we are inside our container. If we run this command uname, we are getting the same username Linux. So this is the basic of Docker. Right now we did lots of things, and if we want to learn what are the things that happens behind the scenes, we need to go to Docker docs official documentation, and we can see that this is the architecture of the Docker. First, this is the client. The client can be your Docker Desktop application. It can be Docker CLI, anything. So here you are running the docker pull command. Then pull command is making the request to your inside your Docker host. There is a Docker daemon. Docker daemon will get the image request, and first it will check if the image is present in your Docker host or not. If it's present in your Docker host, then it will return the image. Otherwise, it will check inside the registry. So what is Docker registry? Docker registry is as a public storage for storing all of this public images. If Docker daemon won't find that image inside your Docker host, it will make a request to Docker registry, and then Docker registry will give that image to you, and then your image will get returned. And then you can make the Docker run request again to your Docker daemon, and then Docker daemon will run the image into a container, because we all know Docker images in runtime called containers. So this is all about Docker. Go share it with your friends. I hope the next video will come out on next weekend. So this is the whole architecture of the Docker. Go share it with your friends. Never forget to chase your dreams.